Okay, the next section of chapter 14 is the predicting the direction of the reaction, which is the second use of the equilibrium constant. And to do so, we're going to use something called QC. QC is the reaction quotient. It's an expression in the same form, which means it's the same algebraic equation, but it's not necessarily at equilibrium. Okay, so what is different here is I would put all of the reactants and products into the pot, and which way does it need to shift in order to reach equilibrium again. So, and there's three different conditions. If QC is equal to KC, the reaction will go left, which means towards reactants. And so you can write down either answer there, left or towards reactants. They mean the same thing. It can go right if QC is less than KC, and that would be right or towards products. And if QC is equal to KC, then the reaction's at equilibrium. And I should say that if it is basically plus or minus, say, 0.1 of the equilibrium, of the same value, I'm not sure if I like that term either. If it's less than 1% difference, then we're going to say it's the same. So in other words, if I got 0.065 is what QC is equal to, and KC was 0.066, I would consider these equal. It doesn't have to be exact. It's very, very close, but not necessarily exact there. Okay, so here's the problem. So here's the figure that if KC is greater than QC, then it will go towards the right, or products. When it's at equilibrium, they're equal. If QC is greater than KC, it shifts left back towards equilibrium. Okay, I like to think of it a different way, and I'll show you that in just a second as we do a problem. Okay, so here's an example of this. Consider the reaction of 2 nitrogen dioxide goes to form 1 dinitrogen tetraoxide, and it gives me the KC. And so it says calculate the value for QC in these two experiments, and gives me the two concentrations. You notice that this is the reactant and that's the product, so it gives me both, and ask me what the reactant quotient, or QC, will be. And what's key about this, and how you can tell it's a QC problem, is it will ask what direction will the reaction shift. So the KC and the QC algebraic equation is basically the same. So QC is going to be the concentration of N2O4 over the concentration of NO2 squared. It gives me the concentrations already, so this is 0.20, and this would be 2.0 squared. So QC ends up being 0.05. Okay. QC then is, less than KC, which means that the 0.05 is a smaller number than this 0.078. Now, you can memorize the left and right if you want to, but I look at it this way. I need this number, the QC, to become a larger number in order for it to equal 0.078. So in that case, would I want to make my numerator larger or my denominator smaller? So a larger numerator means a larger number. A larger denominator means a smaller number. So I'd want to make QC smaller. So in this case, I want to make it larger, and the numerator represents the products. The denominator represents the reactants. So in this case, I want to make a larger number, so that means it goes towards products. So my answer ultimately is towards products, or I can say shifts right. I don't suggest putting both if you're doing an open answer test, because a lot of times people will reverse these, and if you give me the opposite, I have to count it wrong. So pick one, and I'm saying either answer will work, either towards the products or shift right. Okay, either way. I would pause this and try to do the next problem, this one here, before I go over it. QC is going to be the same equation because it's the same reaction. It's going to be the concentration of N2O4 over the concentration of NO2. So it's going to be 0.20 over 1.00 squared. That means that it's going to be 0.2 because I'm basically taking 0.2 divided by 1. So in this case, QC is greater than KC because 0.20 is greater than 0.078. I want to make this number smaller to be this. So if the number's smaller, that means I need to increase my denominator. Which means it shifts left or towards the product. So this is a QC problem. If you see in part of the question, it says, what direction will the reaction shift at all? So when it asks about reaction shifting, that means it's going to be a QC problem, and that's how you identify it. And that is the end of this section.